Can you even see my screen?
Yeah, we see it.
Yeah, you're good.
Okay. Where we started, right?
Yeah.
Yeah.
Okay. Good morning, everyone. Welcome to today's workshop on FEA, also known as simulation. Okay, so we'll start off with defining what is FEA. FEA is an acronym for finite element analysis. FEA is a field of study where you simulate real world phenomenons into a virtualized environment in order to identify certain stresses, deformations, and dislocations in your project in order to not waste any time in real world testing. Um, Engineers use it very often to save time and money, which could be a really huge help for the industry and their company. It is mostly used to determine stresses. In this case, it's mostly uses von Mises stresses. And it also helps you determine stress and strain and deformations, but SolidWorks gives you other options such as determining your safety factor, applying fatigue load, which is repeated load, and it can help you with other things. But for today, we're just going to focus on simple stress, strains, and deformations. So for today, there are many different types of loads that SolidWorks offers that you could apply to your material. But for this case, we will focus on point loads and distributed loads. You would be able to concentrate one load into a single point in your structure. This requires manual uh, tasks because SolidWorks by default only applies a distributed load into the whole face of your body that you're trying to apply a load to. So we will go over that today on how to concentrate the distributed load that SolidWorks has into either a single point, into a shape, whatever you need. We're gonna also talk about meshes. Meshes allow the user to concentrate and focus on single pieces of your material. Um, Meshes come in two different modes, either coarse or fine. Coarse means bigger bigger area pieces of concentration, but there's less of them, which could also be known as less precise calculations. Uh, Fine means smaller areas of concentration, but much more of them, which could also be mean as more precise, as you can see in these two pictures. Before we move on to the setup, we're gonna check if we have SolidWorks simulations installed in the actual program. So if you were to open your file, in order to check if you have the simulation option enabled, you would go to this option tabs and then go all the way down to add-ins. And then you would scroll through all these add-ins all the way down to SolidWorks simulations. You would click these two boxes if not already enabled. Just click OK. If it doesn't pop out right here on your quick tabs, you would just right click anywhere on that and then make sure it is enabled. As you can see, I don't have it. And right click and enable it. Okay. The next step would be to actually start the simulation, which you would click on new study. If you have any like doubts or questions, SolidWorks uh, provides like descriptions of whatever you're gonna use here on the tools. So we'll start off with a new study. Since we're only gonna deal with static simulation, you'll just click on the static simulation. There are different other ones, but those would be talked about in a different day. So click OK, and then you have these menus, which are the core of the static simulation. You have your part. If you have more than one part, you'll have more available here. But for this case, you only have just this one plate. You have connections, which allows you to simulate connection pieces without the piece actually being there, but still get the same effect it would provide if it was there. So we have the spring, which in this case, it would join two locations together, which simulates resistance to tension or compression, or sometimes both. You have a pin, which connects two pieces of bodies together, which allows it not to move away from each other, but it allows them to rotate around a certain axis. And then you have the most common one of them all, a bolt, which is a piece of hardware that connects multiple pieces together. And then less commonly, you have the bearing, which joins two faces together, but allows for moments to occur. And then we have fixtures. We have different types of fixtures, which provides your body of a support, because you can't have static simulations without an actual support. So we have fixed geometry, which is another term for embedded, meaning it's stuck to the ground or stuck to a non-movable surface or piece. And then you have roller and slider, which allows it to stay in one axis, but allows it to slide or rotate on another axis. And then you have hinge, which allows you to rotate in one axis, like a door. And then we have elastic support, which simulates a bouncing motion. Like if you were to put foam under your piece, that would count as a support, but still provide like a different type of type of support to your vibration. Then you have bearing fixtures, where you would add the bearings, allow for rotation, but no translation. And then you have the meat of the whole simulations, which is the external loads. You are able to add actual forces, like mentioned before. Um, SolidWorks always starts off with distributed loads, but you can make these concentrated in any shape you want. Then we have torque, which is moment stresses, and then you have pressure, of course, inside tubes. And then you have gravity, which simulates the piece falling down. Centrifugal, which is mostly for bearings. And then you have bearing loads, which is mostly also applied to tubes. And then you have temperature, which could also be used to apply to this body if there's like any shearing stress that causes thermal thermal expansion or any type of heat, you would be able to use these. But for today's workshop, we would only focus on force and torque and how we could use it in many different ways for common applications of everyday pieces and stuff like that. And then we have meshes, as we talked about before, allows you to concentrate forces into single pieces, multiple pieces, and just focus, allows you to focus on one piece at a time. And then your result options, which would give you your results once you run the simulations after everything is set up. So the first thing you would do to start off would be to apply a material to your piece, because it needs all that information to calculate your resultant forces and your stresses. So if you want to apply a material to your bodies or body, you would right click on the piece, and then you would apply edit material. You would be taken to this window, which has SolidWorks default materials which you could apply. It gives you elastic modulus, Poisson's ratio, shear modulus, mass density, all the information you need for force, stress analysis. If you don't see the material that you're looking for here, you are able to add your own material.
Wait,
For
one second.
example, yeah,
Sorry, Uriel said if you could speak up a bit more.
am I not loud enough?
Um, I don't think he can hear you well. So,
I think you were good volume.
okay. Yeah, just keep going. I might be Uriel.
Okay. So we're on how to add materials, right? For this case, we would for our project in general, we would be dealing with a lot of aluminum. Uh, since SolidWorks doesn't have the aluminum we are working with, in this case TSOT aluminum 6105, we had to add it manually, and you had to search up their values either online or on a piece of literature. So on how to add one, you would right click on the outside, general, which is these folders, and you would go to new library, which would give you a new folder of these. You would name it uh, whatever you desire. Um, in this case, we'd use new steel. Then save it, and then it would pop out right here. If you want to add a new subfolder, you would right click, go to new category, and then you would get a new subfolder. Let's say you have different types of new steels you want to add. 1040 alloy steel, something like that. And then you would want to add your new material, which you would right click and add new material. You could once again name it however you like, 1040 steel. And then right here we have all the pieces you would need to fill out. You could have it in different units if you feel comfortable with certain units. Got SI, English, metric, and so on. You would have to look up, of course, the properties since you don't have them here. Whatever's on red means it's information that's needed for every type of simulation. Doesn't matter if it's non-force, non-torque. If it's thermal, it will still need this piece of information. If it's blue, it's only used for certain simulations. And then once you add your material, once you add the materials you want, the materials you need, you would pick one and just apply. Oh, I didn't finish adding. We'll pick whatever they have here. Let's go with this one. So you just apply. It will change color depending on what they have here. You can add different colors to the materials that you add yourself. So you would close that, and then it would show right here. Before you added it, it didn't have this dash 1040 steel part. That's when you know it applied the material to your body. The next step would be connections. If you have multiple bodies connected through bolts, springs, or pins, you could remove them and add one of these instead. But for this case, we don't have that. We'll go over this in a different example to show how it works in the actual project that we have. But for now, we're not gonna. This doesn't apply to this since we don't have any holes or anything. We could add holes and put it, but for now, We're gonna skip that. Next part is the crucial part, which is adding fixtures. In this case, we'll go with the fixed geometry. If you're not sure how to visualize it, SolidWorks is nice enough to actually give you how it looks uh, in the program. The green means the part where you put the fixture. So just like the load, it does a concentrated fixture, a distributed fixture, my bad. But you could concentrate the fixture. I'll show that how to do that later on. So you would need to add in the face category, where do you want your fixtures? It will show up as these green arrows, meaning that's where your support would be at. You could have them on faces, you could have them on edges, and so on, and points as well. That would be a concentrated fixture. For this case, we would go on the side. You could add multiple fixtures to have support on both sides like this, or you could have it on one side, which allows just simple bending, like seen on the example. But for this case, we would add support on both sides. And then you would click OK. Yeah, it would pop out right here. You could, if you don't like how it looks, you could hide it. If you don't want to, if you don't want to take into account that type of fixture, you could suppress it. It won't come into the calculations. But for this case, we would need it, and we would show it. And then the next part would be to add the external loads. We will deal with force for now, because torque in the simulation is only applied to cylindrical bodies and tubes. For this case, we are not able to apply a torque because it's not cylindrical, but we will go over how to use that in a different example. I mentioned before, it only applies, as you can see, a distributed load, which is only concentrated within the face of your body. And then these are the different types of options. You are able to pick which, if it's normal to your body, or you could pick the direction that you like of your force. In order to pick a direction for your force, you will need edges or lines to help you determine the direction. If I were to want the force going down, I would click on this one since it's going downwards. If I want the force to go sideways, I would click here, as you can see, sideways. You want it down, you would click the one. So technically, you would pick the one that's parallel to the force. You want the direction you want it to go. For a simple example, we just go normal. Right now, it's pushing down, but you could change the direction by reversing it to pulling. In this case, we would do push. Next piece would be how much load would you want? In this case, we would go with maybe around 50 pounds force applied to your body. Of course, you can also change your units if you feel comfortable with other ones. If you have multiple distributed forces, this option will turn on. Actually, let's do it. So let's say I put another to squeeze it, right? Now it would show up per item. It would mean that each force would be 50. This would be 50. This would also be 50, meaning a total force of 100. If not, you could do a total, meaning all your forces combined would be 50 altogether. So 25, 25. In this case, we would go with total for something simple. And then you would click OK. If you don't like how it looks, you could also hide it or suppress it. Now meshes. This would allow you to concentrate on specific areas for your body when it comes to looking at the stresses being applied. You would create a mesh. As mentioned before, you have the option to go between coarse and fine. As seen in the picture, coarse would give you bigger areas, but less sections. We'll see how coarse handles. So you just click OK. As you can see, it's big areas, but there's less of them. Now we're gonna do fine. As you can see, they're much smaller. It's more concentrated forces, or it would show you more concentrated forces. It splits your whole body into different pieces. It's not really recommended to go really fine because it really takes up a lot of power from your computer. So we would just go something in the middle once again. You can just reset it if you want it in the middle. Just click there. Simple. And then once you have all the pieces needed, you identified your material, define any connections you may have, you identify your fixtures, you also applied the forces, and if you want meshes, you can also apply them. The next thing would be to just run the simulation, which you could either do it from here or from here. Mesh or run, mesh and run, or from right here, run simulate, run the study. You would get something like this. It looks really weird. Like there's a lot of extreme bending here, extreme bending here. SolidWorks has a habit of showing you exaggerated deformation, but you can turn that off by either clicking here, which gives you the actual deformation and forces applied, or you could turn it off by right clicking either one of these three and go to settings and go to definition, and right here deform shape, it has it as automatic, which gives you a deformation multiplier of all of this, which gives you the whole exaggeration. But you want to click it on true scale, or if you want an exaggerated multiplier, you would click it on user defined. But for this case, we would just want true scale because it's mostly used instead of exaggerated. You would click OK, and that's another way of getting rid of that exaggeration. If you also want to focus on your meshes, you would also right click on the stresses, and you would go to settings once again, and then right here where it says boundary options, you would click on it and it would pop out as mesh. And as you can see, it will be able to show you where you want to concentrate. Now, how to read this. This is really important. It shows you the different type of levels that these forces are applying to your material, mostly stresses. Red, of course, means it's has a high stress. Blue means it doesn't have a lot of stress applied to it. You could deal with the settings for these by also right clicking on it and chart options. If you want something more simpler, you could tell it to show you your minimum stress. You can move it around if you want. You can also tell it to show you your maximum stress. As you can see, it's right here. If you don't like these range of values, like let's say you don't like your upper limit or your lower limit, you are free to change those by clicking on this box, and you are able to put in your own values. If you don't like the color scheme, you're also able to change it into whatever color you want. Your preference is yours. You're also able to change where you can move the box as well. You could either move it with your mouse, or you could have precise numbers. You can see here. You could change the thickness, wideness of this chart, thick, thin, or just normal. You can also change the notation of your values. If you think you can't read this well, you can also change it to just floating, which just gives you plain, really large numbers if you have really high stresses. In this case, we have simple numbers, which is just these small numbers, or you can have it as general, which removes all zeros. In this case, we would go back to scientific, because we would deal with extremely large forces and stresses later on, so it would be more beneficial to have it in scientific notation. But that's up to you, whatever you want to look at it. So you will click OK if you changed any options. When you do your simulation, it results in 3 default outcomes. Most common one, stress, which gives you, of course, the stress, and then it also gives you displacements, like, oh, was there any deformations anywhere? So if you want to see that, you just right click on it and click on show, because it only shows one at a time. So as you can see, it has the same problem as the stress, where automatically it gives you an exaggeration of deformations. So you would just toggle that off, and you would be able to see the the displacements. As you can see, most displacements happen around the edge. If you're not sure where to see that, you can do the same thing as the stress. Open up the chart options and enable your min and max to help you determine where are your displacements at. Same thing for strain. You would click on show. Same thing, it'll give you an exaggerated deformation. Click that off, and same thing. Right click on the chart options, your min and max. You could write these down, or you could just leave them as is, because later on, if you have time, we'll talk about how SolidWorks helps you write a report of your research here. Uh, it's a really helpful tool. We'll go over that towards the end if you have time. So this would be basic simulation setup. Simple force, simple fixtures, uh, and just simple as that. Uh, Now, let's say you want more information besides stress, displacement, and strain. Let's say you want a factor of safety. Uh, in order to obtain that result, you would just right click on these results, and you're given more options to for results. In this case, you have the safety factor, stress plots, displacement plots, strain plots, and they can also give you equations to show you how SolidWorks calculated the stresses. But most commonly used out of these is the safety factor safety. Mm, yeah, there you go. So you would apply your safety factor. You could either do a specific body, a specific piece, or you could do the whole piece. It gives you that option, like either all or selected bodies. You would click. In this case, we only have one body, so it would be the same thing as all. It would show you the equation it uses to calculate the safety effect, the factor of safety. You can also set up an upper limit to tell you if you pass that limit or you're under it. In this case, it's automatically at 3. You're just click, okay. Yeah, in this case, we used a really low stress, a really low force. So the safety factor would be really high. So it can't really calculate that. So that would be basic simulations using forces, fixtures, and all of that. How to edit your data tables. Now we're gonna go more into detail with how to use these forces and how to like concentrate these fixtures and how to make different shapes of forces uh, with the same example, just in a new study. If you want to do a new study, you would go back to your 3D view and just click on new study once again. Static simulation. And then you're prompted to the same steps again. First step would be applying a material. Let's try a different one. Let's try an aluminum. Listen, close. Now, let's say you want to add a circular concentrated load into this piece anywhere you want. You would need to do a sketch. So a sketch, let's say you want the circular load. Let's say you want it here, anywhere you want. For right now, we'll say right here. You would click OK. The next step would be on features, and it would be in curves. You would need this split line function, which allows you to engrave the drawing you have pointed out onto which face do you want it at, which would be this face. Make sure it's in projection, and now you have your concentrated load. It would either do, when you apply your force, it would either be out here away from the circle, or you could be in here. Now we'll see. Let's apply the same fixed geometry. Let's say let's apply it on this side only. Now when we apply our external load of force, you're not able to do it within this circle. Or you could do it outside the circle. Now let's say you want to add more circles. So you would do the same thing. Sketch. Let's add a rectangle. You would do the same steps. Features. You would split the line onto this surface. Now you have a new concentrated area. Now when you apply your force, it does everything except those two. Or you could do these two. Let's do these two for now. The direction would be assumed normal. Let's go with 300 this time. On force per item, make sure it's whatever you want here. We'll go with per item this time. So each one would be 300. Oh, I didn't go over these simple settings. Let's say you want to change the color. You would just add the color. Let's make it red. Let's say you can't see them either. Let's see, they're too small. You're able to change the length. Higher number means longer forces. Let's say they're too big. Well, you can make them smaller. In this case, let's go back to 100. For your preview as well, if you don't need it, go for it. But it's mostly recommended to actually show a preview. And now, once you have, again, your material, any connections, your fixtures, any external load. Let's say adding different types of loads. Let's say you also wanted a different magnitude of load instead of this 300. You would also do the same thing, right click and add a force. Let's add it to this edge. You can also do it to edges. Let's make it 100. And you want to distinguish your different force types. You can also do it by changing colors or lengths. In this case, since this one's smaller than the other ones, I'm gonna distinguish it by making it smaller. I guess you have to click, if you want it on edges, you would have to click on selected directions. You also need to, there you go. And then you would click OK. Now you have different loads. You have one at 300, and then you have one at the edge for 1. Oh, I forgot. If you think that you messed up, you can just edit it. You have all the options that you applied. In this case, I didn't apply a force, so and there you go. Okay, now it shows that 100. You could add as many as you want, as many forces as you want. You could also add different forces, not just a force. You can also add a torque if you have a cylindrical body. But in this case, you don't have that. We'll go over that later on. So in this case, we're not going to apply meshes just for simplicity. And you would just run the simulation. Yeah. That was the part where, since SolidWorks over exaggerates displacement, it was giving me a warning. Since there's a lot of forces. The more forces you have, the longer it will take to calculate your stresses. You would get something like this. Of course, you would remove it. And you could do any shape you want. In this case, we did a rectangular, we did a circular, and we did edges. Now, let's say you also want to do it with fixtures. So in order to do that, you would do the same thing. You would sketch into wherever you want to apply your fixtures. So in this case, we're going to go to the bottom. Let's say we want it somewhere around here. So we wanted 2 fixtures. You would exit the sketch. Same thing as go to features and split line onto this body. So now when you go back to your simulations, when you add your fixture, it would only focus on that area. Now, we talked about a lot of distributed forces within these areas. Now, how would you do a point load? Just a simple point. So you would do, it would be technically the same process as these, but instead of using the split option, you would use a reference geometry. So let's say you would sketch a line. Let's say you want it around here. Make sure it's construction. You would exit that. You would go to features, and instead of split line, you would go to reference geometry, and you would click on point. Anywhere in this point, if you could pinpoint wherever you want it by just adding like a different line, and you would get the cross section. But in this case, we just add wherever. Yeah. In this case, they added a point at the edge. Let's say you actually wanted a specific point. Construction. Now you would do your reference point. You can see you would click anywhere, and you would click on intersection between these two lines. It would give you the point where you want it. You would click OK, mark as point 1, and then once you do your simulations, let's see, let's add the fixtures. Let's say now we want a specific load at a point. Same thing as the edges, it can only be applied using the selected directions. So you would click on your point, and for your direction, you can have it any way you want. This direction parallel to the direction you want. In this case, we just want it vertically, so this one would be parallel. And as you can see, just a single point force. You would add the force you want. You already have your fixtures. Of course, the first step would be to apply your material. And you would just run the study. You can see just a single point of force. Of course, remove the deformed results. You can add multiple point loads if you want by just repeating the same step over and over again. In this case, I actually showed you its yield. And yield strength in terms of stress means the point that the material could reach in terms of strength without deforming. So a piece could deform, like you could stretch it, compress it, anything to a certain strength. In this case, it's yield. If it reaches anything below that yield, it will just return back to its original shape. If it goes past that yield strength, it will stay deformed. So this chart will show you what its yield strength, and then you are able to compare it to what its highest is, what its lowest is, and you are able to tell if it deforms or not. So this is basic force, on a plate using simple fixtures. Now we're gonna go over how to do torque. Right here I have like a general body of a bolt. Okay, so you would do the same steps as the other one, which is start a new study. Of course, I didn't mention this, but you can also change the name, study. Of course, first step would be apply material. For this case, we're going to use the material we added, or a custom material. It's aluminum, the one we use for our T-slot. Of course, we don't have any connections, we don't have any holes. Of course, for a bolt like this, our fixtures would mostly be right here on the sides. You can see you can click more than two or more than one. And then once you click on your external loads, you may click on torque since you have cylindrical bodies. To use this one, you need to apply what face you're doing your torque to, and then you also need to click a direction as well, like the previous example. So this one's a more detailed version of that. So for face, let's say I want this body to rotate. So for the face, I would click here on this face, and then I want it to rotate counterclockwise. So this piece of the body shows it's parallel to the direction I want it to go. As you can see, it applies it to the edge. Of course, applying somewhere around 20 pound force inches per item. You could also apply multiple loads if you want. In this case, we're just gonna do one, then we're gonna do multiple ones. You'll click OK. And same thing, you already have your material, you have your fixtures, and you have your external load. You just run the simulation. You can see it exaggerates every time. It gives you the information you need. One thing I didn't go over with was how this happens over time. If you want to see that, you just right click on the stress or displacement or whichever piece of information you want to visualize. You would right click on it and go to animate. As you can see, it shows you from the starting point all the way to your maximum torque. You can slow it down. You can see the same thing could have been done for the previous example, but this one looks much more appeasing than the other one. You can slow it down as much as possible, or you could speed it up. Okay. Now let's say you want to edit this and you want to add more torques. Same thing, right click on external loads for torques. It would ask you for the same steps. Let's say I want it here. I want a torque here. Of course, it would ask you for the direction. In this case, I want the torque to apply from over here. So bigger torque, bigger radius. Of course, how much torque do you want? Let's say 100 for now. Same thing, you can also do the one as previous, different symbols. Want some bigger, different colors. Besides that, all the information is put. Click OK. Now you have two different torques. In order to view your result, you will have to click on run the study again. As you can see, it now gives me a new force. As you can see from the previous one, only this one was deformed, but now this one is also deformed. Let's look at it in animation. You can see now this one is included. Now let's say you want to add a new one. Of course, you need you could apply the torque simulation to like any body that isn't cylindrical, but you need a cylindrical body to help you determine the direction. So on the previous example, we could have done torque simulations, but we didn't have a cylindrical body to help us determine the direction we wanted to go to. So we could add one, but since we're already here, we're doing it here. Of course, apply your torque, and then you would have to run again. You see, since in terms of torque, of course, this gets easier and easier since these other two ones are also turning. Now let's say you want to combine different forces. Let's say you want to combine torque and simple distributed loads. So you would do the same thing, force. Since the case it's fixed right here, we would go here. You can see. Let's change the color to distinguish it. Let's make it make it red. And let's make it bigger. Of course, apply the force you want. Maybe 300 as well. And then once again, you would run. Now you have compressive forces, and now you have torque forces. So you are, and then if you want to do point loads, you want to do concentrated loads, you would do the same step you did in the previous example, but of course you would do it and this little piece as well. Let's say you don't want the fixture to be here, let's say you want it here. You can do pretty much all that, all those same steps. Now, we're about to run out of time. Let's do the one that everybody was asking for, which is bolts. This one talks about adding connections, like the bolts, the springs, and stuff like that. So in the robot, in the chassis, we have brackets, and then we have bolts connecting to those brackets. Let's say you want to simulate what happens to the bracket when you apply a bolt to it. So of course, you would do the same steps. In this case, we have multiple parts. In other ones, we only have one part. Let's say, as you can see, multiple parts. You want to apply the same material to all of them. Instead of right-clicking each one, you would just right-click on the parts as general, apply material to all. Let's use the material we always use, which is aluminum. As you can see, applied. All of them have it. Now, let's add the connection. Right-click. In this case, since we applied bolts, we would go with bolts. Now we have different type of bolts here. We have countersinks, and then we have screws and countersinks. We have screws, and then we just have regular bolts. This one simulates bolts and nuts, so it closes on both ends. This one just simulates like the tearing the bolt threads do on the material itself. So we're gonna go with just regular these bolts. So to apply this one, you will need to click on the edge it's gonna start at, and the edge is gonna end at. In this case, it's gonna end right in this edge. There we go. There we go. Now you're able to change the diameter of the bolt head and its diameter of the threads and all that. But in this case, we'll just apply a simple fit. You're also able to select the material of your bolt. In this case, it's by default alloyed steel. You can also change its own properties like elastic modulus of elasticity and stuff like that. You can also include a mass on it. It requires you to apply a preload in terms of torque or actual loading. So this can't be 0. You gotta at least have a 1 or higher. In this case, we're gonna have 20 pounds preload. I think that's industry standard. So you will click OK. As you can see, you're able to visualize this bolt without actually being there or actually including it. Of course, since we're running out of time, you would add more than one. Since I only have one, I would add one for each one. For this case, we're only running out of time, so we're going to do one. For fixtures, you would have to think a little bit here on where your fixtures are. For the robot, the fixtures are here, since that's where it's connected to the T slot, and then right here as well, connected to the T slot. So you would click OK. And since you have everything, you have your material, loads, and fixtures, you would just run. You can see with the deformation, it exaggerates, it sinks in, of course. Remove that. Let's say you can't really see because it's in the way. You would go to the connections, connectors, and hide it. Now you can see clear. You can see, since we only applied a 20-pound force, it doesn't really damage it that much or apply that much stresses. And then you would add many of these to all these holes, and it'll give you all the simulations at the same time. Of course, you're able to see displacement, stresses, and strain, the same thing as the other ones. One last thing I want to go over before we finish is writing the report. Let's say you have a simulation and you want to present it to the boss or the head, the one on top. Simple as that. You just click on the report and SolidWorks does it for you. When it comes to this, you have to make sure you actually put in descriptions like or something. You also make sure you have your assumptions. If you don't want specific data, like in this case, we didn't deal with beams. We didn't deal with sensors. We don't have any meshes for this one or contact. We have connectors, so we will need that. We don't have any loads. We have material properties and all that. And then right here, you would click who made it, which in this case, it would be you. What company? In this case, it would be Casa LA ASME. If you have a website, you would click on the URL. If you have a logo, in this case, I'm going to use the ASME logo. If you have an address, phone, fax, same thing. Make sure the document name changes because it's going to write your report based off of this title. So let's go with bolt sim for this case. You also have a standard paper size, and then you just click on publish. It takes a while based on the amount of information you want to apply. It also captures pictures for you, so you don't have to worry about pictures. If you want a specific picture at a different angle, of course, you would click on include image for report. And here you go, your logo that you included, the title, as mentioned. And then it'll give you all the information you need, date, designers, the study name, which you're supposed to do in the beginning, but we didn't do that. What type of simulation did you do? In this case, we did statics. And then it gives you your table of content, gives you a description. As you can see, you were supposed to write it in before you actually put published. Same thing with assumptions. It gives you your model information, all the numbers you need, where it came from, and then all the pieces that are involved. It even highlights them for you, and then it gives you all the pieces and information you applied to your piece. It also gives you units, what type of units to use. It also gives you references as well, and what type of connectors did you use, the reaction forces. So it splits them up for you.
Jose, can you wrap it up? I think we're over time by 5 minutes.
Yeah, this is all I wanted. It's just the results. That's it. And then it does all the things you wanted it to do. Conclusion, of course, you would need to put in the description. then you just save it, and that's your report. And that would be it. That's all I could cover in an hour. There's a lot more you could go over. Thank you for coming to my TED Talk.